Hello, good morning, grade 11. This is the presentation I used last Wednesday. So we're going to review first before I give you your practice exercises. Okay. First, we discussed last Wednesday about the formula of getting a probability of an event. We say that we're going to use U as a symbol for universal set. And so to be able to get the probability of event A, it is equal to the cardinality of event A divided by or over the cardinality of your universal set. Okay, let's go over first with our basic laws. The probability of a certain event is always 1. And this is your symbol or math notation. At the right side, the second basic law is the probability of an impossible event is 0. So any event that's not going to happen, so you're going to end up having a null set. Third law is the probability of any event always lies between 0 and 1. Okay, now let's have an example, and you had this example last Wednesday, and if you have taken down notes, then you would have had like 2 math notations in your notebook. Okay. If you didn't, here are one set of math notation. Okay. For letter A, you will have 3 over 6. That's getting the probability of rolling an odd number. Letter B, you'll have 1/6 probability of rolling an even prime number. Letter C, the probability of rolling an odd prime number is 2 over 6 or 1/3. And letter D, rolling a number that is prime or even is 5 over 6. So last Wednesday, in your notebook, you would have had these notations that you see at the right side of the screen, and at the same time using notation, using description of the event. Okay. Also, last Wednesday we talked about the fourth law of probability. This is for complementary event. So for the probability of a complement, it is equal to 1 minus the probability of a event. And for combined events, using AND, you will have probability of A union B is equal to the probability of A plus the probability of event B minus the probability of A intersection B. Okay. Now, last Wednesday, we also discussed this example, and this is actually number 1 in your book, exercise 8J, letters A to H on page 354. We already answered this in class, but I'm going to repeat it for those who got confused. Okay, a random experiment is roll an unbiased 6-face dice. Let A be the event, roll a square number, and let B, the event, roll a factor of 6. List the elements of set A. Okay, so in your notebook, you should have had this. You should have this. Set A is equal to 1 and 4. These are just the numbers in a die that has a square number. That's 1 times 1 for 1, and 2 times 2, and you will have 4. That's your square number. Second one, list the elements of set B. B being factor of 6. So set B has 1, 6, because 1 times 6 is 6, then and 2 and 3, for 2 times 3 is equal to 6. Okay. Letter C, show sets A and B on a Venn diagram. Okay, so we'll have the rectangle there for our universal set. Set A on the left side, set B on the right side. I always said that the first thing you do when you have a Venn diagram is always fill out the innermost part of your Venn diagram. So this is your innermost part, which represents the intersection. So for both sets A and B, the common element is 1 because set A has 1 and set B is 1. So you should have 1 in the middle. Now, let's fill out the rest of the set. For set A, you only have 1 and 4. So you already have element 1 here and we just need 4. Okay. For set B, we already have 1 and so then we'll put 2, 3, or 2, 6, and 3. Okay. We still have one missing number or one element that does not belong to either A or B, and that's 5. So we're going to put 5 outside those circles, but it's still a member of the universal set. Okay, so now for letter D, write down the probability of getting A. So first, your math notation, you should have P, then A equal to 2/6. Let's count the number of elements in your set A. You have 1 and 4. You have 2 elements. You have 2 over here. And then you have a total of 6 elements in your universal set. Letter E, write down the probability of B. Write the math notation. You have P and then open bracket, B close bracket is equal to 4/6. Let's count the number of elements in your set B. We have 1, 2, 3, 4. So you have 4 over, you have a total of 6 elements in your universal set. So 4 over 6. Letter F, find the probability that the number rolled out is not a square number. You know that the event for probability A is roll a square number. So we are just negating the event A. So you can write the math notation probability of A complement, okay, equal to, and this is your number 4 law. So you have 1 minus your probability for set A, which is 2/6. So 1 minus 2/6 will give you 4 over 6. Now, if we check our Venn diagram here, all elements outside A, you have 2, 3, 6, 5, and you have 4 elements. So you have 4 over, and then the total number of elements inside your universal set, which is 6. Okay. Letter G, find the probability that the number rolled is both a square number and a factor of 6. Okay, now be careful. It has to be that your number is a square number and at the same time factor of 6. So if you look at your Venn diagram in here, how many elements satisfy both conditions? It should be a square number and at the same time factor of 6. So you only have here 1, and that's the one in the innermost. So you can write your math notation as P probability of A intersection B is equal to 1 over 6. You only have one element that is both a square number and a factor of 6. And count the number of elements in your universal set. You have 6 elements, so 1 over 6. Letter H, find the probability that the number rolled is either a square number or a factor of 6 or both. Okay, so you count all the elements that satisfy just one of those conditions. Okay, so that you will have your math notation as probability A union B, because you want all these elements in set A and also elements of set B. So if you count those elements, you have 1, 2, 3, 4, 5 elements over the total number of elements in your universal set, which is 6. Okay, grade 11. I hope this is clear. We already went over this last time, and so this is just a repetition. Okay. Now, if you're confused, go and watch this video again. Okay, for the next one, this is new, and so I'm going to go over how to solve this problem. A random experiment is toss 3 unbiased coins. List the set of 8 equally likely possible outcomes. Instead of just listing them down randomly, I would like for you to have a system. So I'm going to show you a tree diagram system of organizing or making a list. Okay, so here's your tree diagram of results. For the first toss, you will have in your coin, you will get either head or tail. Okay, now on the second toss, if you get a head, on the second toss again, you may get head or tail. Same in the situation, if you get a tail, the second toss, you may again get head or tail. If you continue to the third toss, you will again get still head and tail, head and tail. Okay, so to list the outcomes, you can go from head, head, and head. You can go head, head, and tail. That's your representation. You can go head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, tail, tail, tail. Okay, so these are all your possible outcomes, and this should be the solution for A. Okay, for B, find the probability of no heads. Okay, for no heads, there's only one situation that has no head. This is the tail, tail, tail. Okay, because you only have one, you can write the probability of having no head is just 1/8. It will occur one time, that's one, and then you have 8 possible outcomes. 1, 2, 3, 4, 5, 6, 7, 8. So that's your universal set. Okay. For the next one, probability of one head. Okay. We need to look at these outcomes. When is it that you only have one head? The first one is this event. It's head, tail, tail. The second one is when you have tail, head, tail. And then the next one is tail, tail, head. So in total, you have 3 occurrences of this event. So you may write probability of one head is equal to 3 over 8 because it happened 3 times, and then you have a total of 8 possible outcomes. Okay, for the probability of getting 2 heads, let's look at the possible outcomes. Okay, how many times will it occur wherein you will have 2 heads? Okay, you have the first one, the head, head, and tail. Then the second one is your head, tail, head. And then you have the third one, which is tail, head, and head. If we take a look at everything, we don't have a situation wherein we will have 2 heads again. So that means we have a total of 3 occurrences. So for probability of getting 2 heads, it's the same as the probability of getting 1 head. It's 3/8. Okay. Now, the last one, the probability of getting 3 heads, if you take a look at the possible outcomes, you will have, okay, this head, head, head. Okay. And it's the only time that it will happen. Okay. If you take a look at the rest of the possible outcomes, you won't have any head, head, head event again. So the probability of getting 3 heads is 1/8. One time here, and then you have a total of 8 possible outcomes. Okay, this is number 5 in your textbook on page 355. Okay, you will continue solving problems. If you want, I already have here for number 5 or number 6, and you can continue it, but solve problems number 2, 3, 4, and 6 on pages 354 and 355. Please do share your solutions or you will be marked absent. Okay. Watch the video again if you are confused or ask me question. Bye.